Hello, my dear students. In this class, I am going to discuss nuclear fission. This is another important phenomena of nuclear chemistry. In the previous class, we understood radioactivity and its types, and we also derived the integrated rate expression for nuclear reactions. The name itself indicates that nuclear fission. Fission means breaking. It involves breaking of a substance. Separation, fission means breaking of a substance. Here a nucleus is undergo breaking. The splitting of nucleus takes place. So this is called as nuclear fission. So why this nuclear fission takes place? So we can understand through this example. So let us consider this example. This is a nuclear reactions. You know the meaning of nuclear reactions and chemical reaction. Chemical reaction is different from nuclear reactions. So in this nuclear reactions, what happened? The uranium 235. So and neutron, the slow moving neutron bombard to this uranium 235. It form uranium 236. This uranium 236 is unstable. Then later it becomes barium and krypton, and it gives 3 neutron. So this is an example for nuclear fission reaction. That means here uranium is split and it forms barium, krypton and 3 neutron. This is the best example for nuclear fission reaction. So it is defined as the splitting of heavy nucleus into 2 small fragments of approximately equal masses by the bombardment of slow moving neutron is called as nuclear fission. Then the next question is, so why uranium undergoes splitting? So why fission reaction takes place in case of uranium? This is important. Dear student, in the previous class we understood stability of the nucleus. There are various factors affect to the stability. The one important factor is N by P ratio. The N by P ratio of uranium is 1.55. That is, it is not lies in the stability belt. It is lies outside the stability belt. So the nucleus is not stable. It is less stable. So to this unstable uranium, again we are going to adding this one more neutron. So at that moment N by P ratio further increases. So when you pass the slow moving neutron to the uranium, at that moment further the stability decreases. That means it is highly unstable after you bombard slow moving neutron to uranium nucleus. So at that moment it's unstable and it break. In order to overcome from the instability or in order to become form a stable nuclei, so then this uranium 236 split into barium and krypton and 3 neutron. Dear student, the reason for the instability or the fission reaction of uranium is uranium 235 and 236 are highly unstable. In order to attain stability, they undergo nuclear fission. Their N by P ratio is increases. So that's why in order to enter into stability belt, they undergo fission reaction. So uranium can undergo n number of more than 50 different types of fission reaction. Sometimes it undergo alpha decay. So there are 50 different nuclear reaction is possible with uranium 235. The one such reaction on bombarding the slow moving neutron is it's going to give barium and krypton. And to give and another why this reaction is important, because this reaction is going to produce enormous amount of energy. For example, so 1 gram of uranium on combustion, that is after undergo nuclear reaction, so it's going to produce around 8.68 in 10 to the power of 7 kilojoules. But if you combust from 1 carbon, the combustion of 1 gram of carbon, it is going to produce just 32.7 kilojoules. You just compare the energy. So 1 gram uranium gives 8.6 in 10 to the power of 7, but the same carbon, so 1 gram of same amount of carbon, it just gives 32. You see the huge difference between the energy which is emitted after these two reactions. That is, one is the fission reaction of uranium, another one is the combustion of carbon. That's why this reaction is special. So it emits lots of energy. And along with that, in order to undergo a fissionable reaction, a proper amount of mass of uranium is required. Why? Because one uranium undergo fission to form barium and krypton and 3 neutron. These 3 neutron again collide with another 3 uranium. It forms 9 neutron along with barium and krypton. So this is how a chain reaction will set up. But in order to sustain a chain reaction, a uranium atoms are required. In every stage, more number of neutron, that is 3 number of neutrons are released. But for 3 neutron, minimum 3 uranium atoms are required. But if amount of uranium is less, so even though the availability of neutron is there, so if the uranium is not available at the moment, the fission reaction do not takes place. That's why a minimum amount of fissionable material in which whose surface permits the escape of neutron, at least 1 neutron, in order to cause further fissionable reaction. So that mass is called as critical mass. That is the minimum amount of uranium, the minimum mass of uranium which is required to sustain a fissionable reaction. It is called as critical mass. So the mass of uranium which is less than the critical mass, it is called as subcritical mass. If the mass of the uranium it is greater than that of critical mass, it is called as supercritical mass. Dear students, so if we discuss three types of mass. One is critical mass, so below which subcritical mass, so above the critical mass it is called as supercritical mass. So it is necessary in order to sustain a nuclear reaction. So then there are two modes of release of energy takes place in nuclear fission reaction. One is uncontrolled fission reaction or uncontrolled release of energy, and controlled fission reaction. So in case of uncontrolled, so you know that this reaction takes place only after bombardment of neutron to uranium. Suppose if you control the number of uranium, what happens? The rate of reaction is less and only a few number of uranium undergo a reaction. So everything depends on this number of uranium. Suppose if you are not controlled the number of neutrons in this reaction, so the reaction continuously it's going on, so up to the completion of all the uranium atom. So this is called as uncontrolled. In uncontrolled case, so we are not going to control the number of neutrons. So you just observe in this reaction. So one uranium is going to produce 3 neutron. These 3 neutron further collide with another 3. It gives energy. Then it produce 9 neutron. So like this a chain reaction will set up. So in every stage, so more and more number of uranium atoms are involved in the reactions. So there is no control over here. So here in this situation, what happens? Enormous amount of energy, that is lots of energy is released at a time, and it get exploded within the fraction of second, and it release large amount of energy. So this is a basis principle. So it is used to prepare atom bomb, which is used in the war. Got it? So this is called as uncontrolled reaction. In case of atom bomb, so once the reaction is initiated, so it is going to complete up to the completion of uranium. So here there is no control over number of neutron. But in case of controlled nuclear reactions, what happen? Here we are going to control the number of neutron. So this controlled nuclear fissionable reaction is performed in a device. It is called as nuclear reactor. So here the reaction is controlled by absorbing a neutron. So for this, so we are going to use cadmium rods. So cadmium rods, so these are called as controlled rod. So if you insert cadmium rods, these cadmium rods absorb the neutron. So when the number of neutron is absorbed at that moment, so only a few uranium undergo reaction. So this is we can control by using cadmium rod. That's why it is called as controlled. And we can also slow down the neutrons by using a substance called as moderator. That means by using control rods like cadmium rods and moderator, we can, but through moderate we can slow down, as well as we can reduce the number of neutron which is created in the chain reaction. So that's why it is called as controlled nuclear reaction. And here uranium is a fuel because it's going to produce vast amount of heat energy, and by using this heat energy we can convert into electrical energy, that I'll discuss in the next slide. So nuclear reactor. So as I said, nuclear reactor is a device. It is used to perform a controlled nuclear reactions. So by using nuclear reactor, we can produce lots of electrical energy. Nowadays, so in many countries, so lots of electrical energy they are going to produce by using nuclear power plant, that is nuclear reactor. So now let us see the important components working of this nuclear reactor. So nuclear reactor has some important components. The first one is fissionable material. In nuclear reactor, the fissionable material is uranium-235 or plutonium-239 is commonly used as a fissionable material. And so graphite or heavy water which act as a moderator. As I said, moderator is a device. It is used to slow down the neutron. So you just observe here. If you pass so usually we are going to use water. So water or graphite rod has a moderator. If you pass the neutron through water, so the velocity of the neutron is reduced, or they slow down and they slowly bombard. So when it's bombard with high velocity at that moment, that much energy is not produced. So if it is slowly bombard to the uranium, you just observe here. So this is a neutron, so which is passing in a water medium. So moderator, and these are the uranium rods which is present in the nuclear reactor, uranium rods. And so these are slowly moving neutron. They are moving and they are collide with this uranium. So here water or graphite, heavy water or graphite used as a moderator, and cadmium rods. So here, so between in the nuclear reactor, it having assembly of so uranium rods. In between we are going to place cadmium rods. So these are the cadmium rods, the blue color rods. So whenever they want to control the nuclear reaction, at that moment they are going to insert the rod between the uranium foil. So at that moment they are going to absorb the neutron. So instead of they are going to collide with the uranium, they are absorbed by these cadmium rods. At that moment the rate of the reaction get reduced. So that's why the cadmium rods are called as control rods. Then so a lot of heat energy is released during this process. So this heat energy is absorbed by water and it converted into steam, and this steam so helpful by using this steam, then this steam is passed to turbine, and this turbine is going to produce electricity. So nearly a 1 kg of uranium is produces heat energy. It is equal to 2000 tons of coal. So you observe here, this is the assembly arrangement of various components of nuclear reactor, and this is how the energy is produced in the nuclear reaction. So as soon as the reaction is started, it's going to produce lots of heat energy. So this heat energy, so when this heat energy is passed up to here, and the water which is present in this container, it convert into vapors, and this vapor passed and so meet the turbine, and they are going to create this turbine movement, and by this turbine movement they are going to produce electricity. So this is the working of nuclear reactor. In the next class I am going to discuss another phenomena, that is nuclear fusion.